South Korea sent a camera to the moon specifically designed to see into the darkest places that have never received sunlight. And what it photographed inside those craters is changing how scientists think about water on the moon. These are not just dark spots. They are some of the coldest places in the entire solar system. And the images coming back are the most detailed views anyone has ever taken of regions that may hold the key to permanent human settlement beyond Earth. South Korea's first lunar orbiter, called Danuri, also designated the Korea Pathfinder Lunar Orbiter, or KPLO, launched on August 4, 2022, aboard a SpaceX Falcon 9 rocket and entered lunar orbit in December 2022. It carries 6 scientific instruments, one of which was developed in collaboration with NASA, the ShadowCam. This instrument is the most light-sensitive camera ever sent to the moon, designed with a sensitivity approximately 200 times greater than the camera on NASA's Lunar Reconnaissance Orbiter. That extreme sensitivity exists for one purpose: to photograph the permanently shadowed regions of the lunar South Pole, crater interiors that have not received direct sunlight for potentially billions of years. The geometry that creates permanently shadowed regions is specific. Near the lunar poles, some craters are deep enough that their floors sit below the local horizon, as seen from the sun. Because the moon's axial tilt is only about 1.5 degrees, far less than Earth's 23.4 degrees, the sun never rises high enough above the horizon to illuminate these crater floors. The result is permanent darkness maintained over geological timescales, potentially billions of years. In that permanent darkness, temperatures can drop to approximately -163 to -223 degrees Celsius. At those temperatures, volatile compounds, water ice, carbon dioxide, ammonia, methane, can be trapped and preserved almost indefinitely. The water ice is the most strategically important. For NASA's Artemis program, which targets crewed landings near the lunar South Pole, finding accessible water ice is essential. Water can be used directly for drinking, electrolyzed into oxygen for breathing, and split into hydrogen and oxygen for rocket propellant. ShadowCam began returning images of permanently shadowed regions in early 2023. The images revealed interior crater surfaces with extraordinary detail: boulder fields, impact craters within craters, slope variations, and surface textures that are critical for landing site evaluation. The images also showed bright anomalies in some shadowed regions, patches that appear brighter than the surrounding terrain in the low-light imagery. Interpreting those bright patches requires caution. They could represent frost deposits, thin layers of water ice or other volatiles that settled on the surface from sublimating ice elsewhere on the moon. They could also represent areas where surface disturbance, such as small impacts, has exposed fresh, less space-weathered regolith that reflects more light. Distinguishing between these possibilities requires additional data from other instruments. NASA's Lunar Reconnaissance Orbiter has been mapping the moon since 2009, and its instruments, including the Diviner Thermal Radiometer, have mapped the temperature distribution across the permanently shadowed regions. The Mini-RF radar instrument has detected roughness characteristics consistent with some ice presence. The LAMP ultraviolet spectrograph has found evidence for surface frost on cold pole-facing slopes outside the permanently shadowed regions. The Danuri ShadowCam adds a new dimension: high-resolution visual imagery of the interiors themselves. Where LRO could only image these regions during brief periods of indirect illumination, light scattered off crater walls or the Earth, ShadowCam can image them continuously, with sufficient signal-to-noise for detailed geological analysis. In 2024, Danuri's science team published results showing surface features inside the permanently shadowed regions consistent with mass wasting events. Material sliding or rolling down slopes, which indicates the terrain is actively shaped by processes including thermal cycling at the crater rims and small impacts. The floors are not smooth and flat. They are geologically complex in ways that affect landing site safety assessments. The combined picture from Danuri, LRO, and ground-based radar is converging on a clearer, but still incomplete understanding. Water ice is very likely present in the permanently shadowed regions, concentrated in the coldest areas, possibly buried under a thin layer of desiccated regolith. Getting to it, and using it, is an engineering challenge that missions later in this decade are being designed to address. Follow for more on what orbital missions are revealing about the moon's hidden resources. And tell me, if water ice at the lunar South Pole can be confirmed and extracted, does that change your view of the moon from a place we visit to a place we could actually live?